Hello guys, CodeChef here. We are going on with our 29th exercise named Ambiguous Permutations. Uh, let's see what it tells from us. It says that some programming contest problems are really tricky. Not only do they require a different output format from what you might have expected, but also the sample output does not show the difference. For an example, let us look at a permutation. A permutation of the integers 1 to n is an ordering of these integers. So the natural way to represent a permutation is to list the integers in this order with n equal to 5. A permutation might look like 2, 3, 4, 5, 1. Or so because n is 5, the numbers which are going to be used are 1, 2, 3, 4, 5. This would be a permutation again, 1, 2, 3, 4, 1, 2, 3, 4, 5, or it could be 3, 2, 4, 5, 1. Every possible combination of those numbers would be a permutation. So it says there that however, there is another possibility of representing a permutation. You create a list of numbers where the ith number of the position of the integer I in the permutation. So this is the first array, and it says that this represents the position of the number I. So if I starts from 1 and goes until it reaches until to n, then this tells the position of the first one, this tells of the number 2, this tells the number 3, this 4, and this 5. So and this they call this inverse permutation. So for example, in this case, the first one is 2. It says that number 1 going to the position 2, number 2 goes to position 3, number 3 goes to position 4, number 4 goes to position 5. As we go on, that's how we count, and number 5 goes to position 1. So as for result, we have this. An ambiguous permutation is a permutation which cannot be distinguished from its inverse permutation. So they both are the same. For example, the permutation 1, 4, 3, 2, for example, is ambiguous because its inverse permutation is the same as this permutation. For example, it says the number 1 is at the first place, the number 2 is at the fourth place. Yeah, the number 2 is at the fourth place, the number 3 is at the third place, and the number 4 is at the second place, which is like that. So we need to check if the inverse permutation is the same with the normal permutation that we enter. If they are the same, that permutation is ambiguous. And there are some input specification. First line, we input the number of test cases. After that, we read the array of the permutated array, and we don't know how many test cases are there. So we have a while cycle until we read 0 for n. So the first step we are going to do here is declare n, which is the number of elements in that array, and we have a do. I'd go with the do while cycle, or we can do something like this. First we read n, and we say while n and at the end we read again n. So at the beginning we declare an array of n elements, and to read that array, which is our permutated array, okay, and also we need the reversed one, the inversed one of n elements, and we have next for, we can do both in the same time. Okay, let's go like this. So while reading, we read the first element and we say that if this is 2, we have I0 because at the arrays the starting index is 0. We'll make some +1 -1 increment decrement by 1 to get the numbers correctly. So the inverse of a of I, which is the value of this, if the value of this is 2, the arrays indexed are 0 1 2 3 4 and so on. It means that the second element is at position 1. That's why we are going to get 1 minus that number, and this would be I. It should be I, but because I starts from 0 and our permutation starts from 1, we need here to add +1. And this is how at the same time we read the input and we create the inverse one. And now we need to check for, we'll get here bool flag. Let's say that those permutations aren't ambiguous. So we start from the first one, go to the end, and let's read once again the ambiguous station. Yeah, now we need to compare the arrays that we had. If the beginning array is equal to the inversed one, it wouldn't be flagged because we need all elements to be the same. So it should be a counter starting from 0, and if they are the same, we increase the counter, which means 0 1 1 2 8 n elements. And if the counter is equal to n, then we print ambiguous, I guess. Yeah, we print ambiguous if it's ambiguous, and otherwise we print not ambiguous and a new line. So what does this mean? If all the elements in the array are the same in the inverse and in the original one, then they are ambiguous. Otherwise they are not ambiguous. What does this while means? This while means that unless n is 0, this cycle will go on. So let's get this, try to submit it. Firstly, run and check the test cases, the test case that we have here, and that's this. We need to get ambiguous, not ambiguous, and at the end ambiguous. Running, yeah, that's correctly, and we go on submitting it and waiting good response from the service. Yeah, that's correct. We have a runtime of 0.13 seconds. Thanks for watching. That's all about this video. Don't forget to subscribe by clicking the red button right below the like button. Also, turn on notification by clicking the notification bell to not miss the upcoming videos. See you soon on Code Purpose.